Welcome to this next video on OCR A-Level Chemistry. This is Module 2.1, which is Atoms and Reactions. And in this video, we're going to be looking at empirical and molecular formula. So first, let's start off with empirical formula. And I might have to make this a bit bigger. Empirical formula. I did not mean that. So I want to change it to blue. An empirical formula. So empirical formula is simplest whole number ratio of atoms of each element present in a compound. Present in compound. So that's what the empirical formula is, the simplest way of showing a chemical formula. And it shows the ratio between elements rather than the actual numbers of atoms of each element. Although sometimes the empirical formula will match this. An example of which is ionic compounds. So ionic compounds such as NaCl, sodium chloride. That is an empirical formula, but it's also its proper for chemical formula. Giant covalent compounds, SiO2, that's its empirical formula, also its chemical formula. So you can calculate empirical formula if you know the mass of each element in a sample of a compound. So you can calculate using the following steps. So how to calculate? So calculating empirical formula. First step is divide amount of each element, amount of each element by molar mass, by its molar mass. This will get you the molar ratio. This will get you the molar ratio. The second step is you take that molar ratio, divide the answer for each element, divide answer for each element by smallest number, as in if it was like 3 6, you divide by the smallest number, which is 3. So you get 3 goes down to 1, 6 goes down to 2, 1 to 2. So smallest number to get the ratio down to a 1 to h. So you want ultimately the ratio to be that. And then you need to multiply if necessary. So this third step is, if necessary, multiply answer by suitable number, suitable value to get whole number ratio. So instead of it being, say for example, if x here was 1.5, you would multiply by 2 to get 2 to 3. There you go. So let's look at an example for this. I don't have a ChemCalc series, a ChemCalc video on these, but I hope to do one. I don't think I have a ChemCalc video planned for this. Yeah, I don't. So let's do an example. So let's do a couple of examples, and then so this is example 1. So here, let's use the example that they have in the textbook. So analysis. So that we have magnesium. Magnesium we have of 0.6 plus bromine, which is 3.995 grams, to form magnesium bromide. Calculate the empirical formula of this compound. And in here, they've given you the molar mass for both magnesium and bromine, but I'll show you what they are. Splash up I'll put up the periodic table on screen now, and then you can see for yourself what the molar masses for Mg and Br are. But they're given in the textbook, so I'm going to use the values in the textbook. So they're giving us that Mg, so let's start off. So the way I like to organize this is to do Mg on one side and then Br on the other side, and just work my way down like that. So we have here 0.6075, and then we do a little thing here to 3.995. Okay, so now we're going to divide that by each of their molar masses. Again, I'll splash up the periodic table on screen so you can see what the molar masses of Mg and Br are, but I'm going to use the values they give in the textbook, which is 24.3, and Br is 79.9. So if you divide that on your calculator, they've given the answer here. That should give you an answer of 0.025 to about 0.050, 0.050, and then you divide that by the smallest number. So you divide both of these by the smallest number, 0.025, 0.025, and that gives you 1 and 2. So the empirical formula is equal to MgBr2. So you can see it's a 1 to 2 ratio of Mg. So every one part of Mg, you have 2 Br. So essentially, every one atom of Mg, you get 2 atoms of Br. So our final answer is MgBr2. So that was empirical formula. Now we're going to look. Should I move it onto the side or not? Actually, I'm going to go down. So now we're going to look at molecular formula. So molecular formula So molecular formula are used for compounds that exist as simple molecules. So they're used for simple molecular compounds only. So molecular formula tells you the number of each type of atom that makes up one molecule. So for example, a propane molecule, I'll draw a propane molecule here. So we have a propane molecule here. We have 3 carbon atoms, as you can see. So our molecular formula would be C3. 8 hydrogen atoms, so 1, 2, 3, 4, 5, 6, 7, 8. So we have, so this C3H8 is the molecular formula for propane. But you can, now obviously you're not going to count every single thing, every single atom in that. You can calculate it. So, but for some instances, the like in the case of propane here, the molecular formula is the same as the empirical formula. In some other cases, that is not. In some other molecules, that is not the case. So let's take, for example, let's take butane. So let's take butane. Here's a molecule of butane. You can see that the butane molecule is C4H10, and this is for butane molecular formula. But if we want to work out the empirical formula of butane, we divide each of these by the highest common factor. We divide each of them by the highest common factor. So here it would be 2, so you get reduced down to C2H5. So here we divide it by the highest common factor of 4 and 10, which is 2. You divide 4 by 2, you get 2. Divide 10 by 2, you get 5. So the empirical formula for butane is actually C2H5. A little tricky there. So we can calculate molecular formula from empirical formula. If we know the empirical formula and the relative molecular masses of compounds for experiments. So let me say that again. We usually find empirical formula and relative molecular masses of compounds for experiments. We can use those results from those experiments to find out the molecular mass of a compound. So the molecular mass of a compound must always be the same as the mass of the empirical formula, or a whole number multiple of it. So for instance, let's have a look at an example. Example 2. Let's have a look at empirical formula. So the empirical formula in this one is CH2, and the molecular mass, so MR, is 56. And we need to find the molecular formula. So here, what we will do first, we'll do to find out the empirical formula mass of CH2. So we need to find out empirical formula mass of CH2. The way we do that is we add up all the relative atomic masses. So here we do 12 plus 1 times 2, and that is equal to 14. We then work out the number of CH2 units in one molecule. So number of CH2 equals 56, because our mass number is 56, divided by 14.0, and it gives us 4 CH2 units. So our molecular formula is then equal to 4, because the times CH2, so you do, imagine here there's a little 1 down there, so 4 times C1H2, but we don't write the 1, 4 times 1 is equal to C4, 4 times 2 is equal to HH. So that is our molecular formula, and this in fact is actually, I think it's butene, yeah, and this in fact is butene, our mystery compound. So that is it for molecular and empirical formula. So that is it for this video here. In the next video, we're going to be looking at ideal gas equation, gas volumes and moles. And this is where the maths really starts to come into play for your course. Anyway, that's it for this video here in the next, and I'll see you all later. Thanks for watching. Goodbye. Goodbye.